y'all be careful out there. Hey everybody, so this is an Ohio shaper I found at the scrapyard a couple years ago. I'm just getting around to the video now. It's a pretty long one. So I bought it. I think it was about 800 bucks. At 20 cents a pound at the time, that's going to be about 4,000 pounds. I went home really slow, I'll tell you that. But we got it loaded, got it to the house. I had to move a couple of machines that I had in the garage out of the garage because they're in the way. That old Becker mill and the lathe had to go get tarped up. Here we go, folks. Moving a 1900s lathe in 1900s style. Alright, so now we got to move this old mill. Figured I'd film. We'll see if I can do it, but this is how you lift up something and you don't got nothing. Yeah, or it's really low to the floor. There's only like a little access point right there for a crowbar. So what we do, it's not that. Get it close. Get the crowbar under there. I'm going to put my foot on it. And kind of stand. So push it down from foot. Lift up our machine. And then take the other foot. Kick the other block in. On that side. Kick the other block in on this side. And then I let it down. And now we're 2 blocks tall. So I got it up on the rails. I'm going to take some lag screws, and you see all these old machines have mounting holes in the feet, so I'll just lag screw through the mounting holes to hold it on there. And I set the weight on this one further back on the rails so the front of the rails get a little leverage, and that way they don't dig in so bad. And hopefully this is enough timber that it's not going to snap when we get up to that bump in the front. So we'll get her screwed down and set the chain and take a long walk with it, 30 feet that way. So here we are, fresh off the trailer. It's about 3 feet off the ground. It's a little sketchy because, well, that's a 3-ton hoist. Should be fine. But I'm going to set it down on that I-beam with some crossbars on it here in a second. We're going to lower it down and kind of bump it over, and then I'll grab the back end and line it up and start looking at welding it. Hey, sports fans. So let's talk about fixing this shaper and our apocalyptic lighting. There's smoke in the air pretty good today. So it's broke off right here and pretty greasy. This is a recent break. They dropped it when they unloaded it. So I'm going to put a grinder on the old Makita, and I need to bevel this and brake clean it, get all the grease off of it, and then I'm going to heat it up with a torch a little bit. Not to preheat it, but just to get the grease out. I'm going to go ahead and try and bevel the webs, see if I can fix that, and I'll set up the old tripod and maybe do a YouTube video of experiments welding this whole thing up. I want to try a couple of things because I don't want it. Cast rod's it's about 50 bucks a pound. It's very expensive, so I don't want to use all cast rod, but we'll see how it works out. There's our little Clark truck loader in action. Saves my back. I got this 20-inch Ohio shaper, and the back motor mount, back part of the casting broke off. It's pretty decent cast iron. It's got some webbing in it, so we're going to work on figuring out how to stitch it all back together. I'm going to try some nickel rod welding, some stick arc welding, etc. And maybe braze it, maybe plate it. It's kind of a tricky piece just because of the way it broke when they dropped it. But first step, I'm going to get the motor off of here, get these parts cleaned up, start grinding bevels. So we got to give her a bath. I put some simple green on this, kind of scrubbed it in. A little Harbor Freight electric pressure washer is kind of handy. So just out the gate, this isn't going to be a perfect repair. You can see this crack right here. That piece has to come out, so there's going to be a hole right there. I'll probably braze it in or something later, but I'm going to knock it out the rest of the way, and this will give us a sample piece to test some of the weld rod on and see how it bonds, just to see. It kind of, looking at where these webs broke, you can see that the bottoms are kind of rusty, so I'm wondering if these weren't cracked before for some reason or other, maybe a casting problem or something, and then they just didn't finish it off when they dropped it. There's our sample. Yeah. Focus, focus, there it is. Sports fans, so it's hot, it's 103, it's muggy, but we got stuff we got to do today, and let's talk about it a little. So I got back to this shaper. Some other projects are run out, and what I have to do first is bevel back this material so that I have a little bit of contact down here at the bottom, and then when I place my welds in, I'll have a nice spot where I can get in with the rod and fill that gap. I'm going to use a skinny wheel to cut off a bunch of this stuff, and then on this matching piece over here to make like a 45-degree bevel or so. And then I'm going to have to bevel these, because when I'm done welding the top, I'm going to jack it up, reach underneath, and just drop a nickel rod pass on those just to kind of hold them together, because the only thing this back piece does is hold the motor on. So I'm going to get started on that, and I'll update you here in a bit. Smoking pretty bad, and it's because cast iron is very porous, and so this is saturated with oil. So part of the challenge here is going to be, I'm going to have to come back with a torch and warm this up and clean it off a few times to try and bake enough of that oil out so when I go to weld it, it's not trying to contaminate my weld. So one of the problems with cast iron, like you can see right here, is that a lot of the times, even out of the box, there's already cracks in it from the factory. You can see, well, kind of. Anyway, you can see, oh, there it is. Damn it. This is, there. So, you can see all these little voids and crack that were in that iron before I ever got here. So when you're welding this stuff up, there's no way to tell, you know, how much is under the surface, if there's pits and stuff like that full of graphite. Makes it a real challenge to get a good solid weld in. Hey everybody, so early in the morning here, before I start doing loud stuff, we're gonna go and preheat this cast iron. Last night I got the bevels more or less done. We've got chains and binders to hold the piece in place, and then I'm gonna take the oxy torch here and heat up this surface to boil out all the oil. It's just set overnight and it's already got oil on it. There's just so much oil in the cast iron that it just has to sit to come to the surface. So I'm going to heat it up and try and cook some of that out before we go and try and weld on it, because when we weld on it, we're going to cook it out anyway, and it'll be fine. It's just something else to deal with, and if I can get some of it out now, it'll save us more time in grinding later. So we'll do that this morning and see what happens next. Everybody, so I cooked it. Oh, here, let me show you. So I took my welding tip on my oxy torch and I heated up that cast iron to cook out some of the oil that's in it, because it's pretty spongy and it's full of oil. And now I'm gonna grind that off, or grind it a little bit, to get a good clean surface, and then we're gonna start sticking some nickel rod on here and see how it goes. And I'll show you how that works here in a minute. Okay, we're going to start stitching this together with this Certanium 899 I got from the scrapyard, which it doesn't want to focus on it now, but had it a second ago. Anywho, this stuff. And we'll just kind of see, it's a high nickel rod, and we'll just kind of see how it does. I'm not going to heat this up because that'd be completely impractical. We're going to do about a 1-inch stitch and then hit it with the air hammer to knock the stress out of it, and then do another inch stitch and start closing up this root. I'm going to run it at 90 amps and see how it goes. I might need to turn it up. Hey all, so here's kind of how the process goes. So I'll lay a stitch. These are the root stitches, and you see how I got some porosity in there, but I'm not super worried about that because the cast iron itself is pretty porous, and as long as I got something holding it together, it generally is okay. But that's nickel down there in the bottom. And as you start welding the nickel, see it kind of spatters around. It doesn't like to behave particularly well. It gets a lot of porosity. So I'll do like a base coat where it's shitty like that, and then grind it off till there's just a little bit of it left, and then kind of go over it again. And once it's welding nickel on nickel, it's pretty good. And then once I get kind of a channel built, I'll take some 6013 and weld 6013 to the nickel as a filler, and just kind of build it out until I get a nice amalgamation of metal there, and generally not that many cracks, or any. So we'll just keep chucking away at it and see how it goes. So here's a little update on how this works. And you see all those little bird poopy looking things there with all the porosity in them. And what I do is I'll grind it down to where there's like one layer of bubbles. I want just a thin layer of nickel between the casts, because anytime you touch this cast with a welding rod, you're pulling contamination and all kinds of nonsense out of it, and you're going to get porosity. It's just part of the program. But after you do the first layer and grind it off, things start to smooth up a little bit. You've got pretty good bond with the nickel. It bonds on there really good. And if you grind out the porosity till it's about one layer and you don't have encapsulated bubbles, then when you go over it with the next pass, it just kind of covers it up and makes it, or it doesn't cover it up, but it fills up the little holes and makes it pretty smooth. And like I said before, if you grind or cut on this cast iron in any given place, you're going to find holes in it. So it's just kind of how it is. We'll just keep working on making these surface layers, and then I experimented over there with filling it with 6013 and it worked fine, so I'm going to try that on the next section and just kind of keep working my way across. So I'm going to bag it for tonight, but here's how far we got. About 6 inches of the crack filled, the first fillet, and then I got this corner done pretty good. And I'll get the other corner and start taking the chain off. There was a little crack that formed, and I had to grind it back out and then just tack and clean and tack and hammer and tack and clean until we built it up. Took a little bit, but looks pretty good. Need to fill that low spot. Yeah, I'll take another crack at it tomorrow afternoon. Hey everybody, so I got a couple hours tonight. We're going to see if we can get this piece filled in here, start stitching this together, so maybe I can get the chains off it tonight. Hey everybody, so I'm welding on this thing tonight, and I figured I would kind of describe what I'm doing because I can't hold the camera and weld, so we'll walk through it here. So this is the weld I've been working on. You can see back here where we kind of finished up, right? And then here where we got some beads laid in there, and right there, all those little peen marks in there, I take a hammer and every time I lay a tack, I go and peen it out. That one's not particularly good. See how flattened out this is? That's from the air hammer. I'll come in and just smash it. And it's mostly because every time you weld, the hot metal contracts, and that puts more stress on the joints. So if I go and hammer it while it's still a little warm, it helps expand it. All right, and then you see over here where it looks real bird poopy. So that's where I start with the nickel. I'll take the nickel rod, and I've got it about 150 amps, and I'll lay a tack and it just kind of disintegrates, and I'll lay another tack and it disintegrates. But if you knock off where it disintegrated, or you start to get a little porosity like this, you start to get a bond. And so you can go over it with the air hammer and smash it down and grind it flat. And basically what we're doing here is we keep tacking on it and knocking it away until we get a good layer of nickel that's actually bonded to the cast iron. Because the first time you tack it, usually there's enough crap in the cast iron that it just boils it off or it won't stick. But eventually, if you keep after it, you'll get something that sticks, that's got good bonding. I don't know if I want to call it penetration, but it sticks to it pretty good, so you can't knock it off with the air hammer. All right, and so we build that up until we get kind of a nickel layer in here, in the, I don't have words right now, in the little valley here. And then, once we have the nickel layer built up, I'll come back in with this stainless rod. Now this is a 10% nickel stainless rod. And I'll lay that right in the middle of that nickel layer. And it flows out nice. It's kind of this is what it looks like over here when it flows out. It just flows out real nice. If I touch the cast iron with this by itself, then it balls up and it looks bad. And if I weld it straight on the cast iron with it, this has too much steel in it. It would suck carbon up from the cast iron, contract, harden, and crack off. But with the nickel layer in there, it keeps it from sucking up carbon from the ambient steel, and I do hammer this out too, or I do it in little passes so there's not so much stress on it. So I'm not trying to have the weld tear itself apart. So if there's little voids and stuff along the edges, then I'll come back with my nickel rod and I'll tack, you know, like right here, tack, until I fill those up, and then we grind them off smooth, and eventually it'll look like this, where it's just bonded metal. So I'm just gonna keep working my way this way. I gotta fill that hole. That's gonna be interesting. I've never filled a hole in cast before, so I don't know what I'm gonna use for filler. And then we got to go around the edges and jack it up and get underneath and do the gussets. Hey everybody, so I got the top weld done, more or less. I still got to fill that hole up and this little spot on the side. But right now I got her up on stands because I got to go underneath and we need to weld up all those braces, all those gussets. So that's next. Now, so it took a while, but here's our finished product. Here's the side, over the back, filled in the hole. This corner was a little bit hard to get at with that pulley in the way. And then underneath here, they don't look very good, but they're all welded. And I found something, since it was up in the air, that was kind of interesting. So when castings are made in the factory, a lot of the times they're not perfect or they have cracks in them, and instead of throwing them away, you'll often find, where was it? You can see here, there, and there, this casting was welded after it came out of the foundry. Just probably a in-process repair. Kind of fascinating. Alright, so the next step is I got to get this off the stands, and we're going to move it over there onto the multi-rollers and start sending it home in the garage, because it looks like we may actually get rain and you know, rust and all. So it's a little overloaded, but I moved a lot of equipment on this A-frame. I'm going to get it down to the ground here, or close, and then I'm going to drag it over carefully until it's over the roller. Got some pins for the roller, and pin it in, and we'll start laying track to the garage. Usually going that 20 feet takes a couple hours. And so far, I've never had to have a tip over. Hey everybody, so today we're going to go ahead and move the shaper from where it's at over here about 10-15 feet this way, into its new spot in the shop over here. I guess I'll take some pictures and whatnot to kind of show how far that little path of travel is and how long it takes. It'll be probably an hour or two to get it going. So that's today's little project. From there to there. Hey everybody. So I'm going to go over, I came up with a new setup. I'm going to try it and we'll here. So I have, when I put the floor in, I made a little spot for a door pin. I got a 1/2-inch bolt in there, and I'm going to hook that to this little 1-ton chain hoist, and then use that to pull the shaper into the shop. And the way I can get away with this is because this is all going downhill. So the tendency is going to be to keep this hook real close to the concrete and keep that bolt in shear. If it goes up high, then it's going to want to bend the bolt and rip it out, give it leverage. But if I keep it low, it should be pretty strong. And we'll see how that works, because I haven't done it that way before. So this works really good. There's not a whole lot of pull on it. We're maybe using 200-300 pounds of force. And it's coming right along. And I can watch the rollers from here and see if they go sideways. So this is actually a really nice setup. I wish I'd have thought of this sooner. This would have saved me a lot of work. Oh well. Live and learn, right? Well, this is working swimmingly well. As you can see, we've made up a lot of ground and it didn't take very long. And so I'm going to pull it into the shop here. And then kind of shift her over and use the bar to push it into place. And then we'll be done.